So in this video, we'll take a look at further examples of solving systems using the substitution method. So solve, solve. Again, I'll use my two colors. 6x plus 2y equals to 4 and 5x plus 3y equals to 6. Okay, so now remember the first step of the substitution method is to pick one of the equations and solve it for one of the letters. Now, this problem you really have to be careful about which letter you solve for. If you pick the wrong letter from the wrong equation, you will end up with fractions. So you have to do a little thinking. So let's take a look at that first equation. If I try to solve for x, at some point I'm going to divide by 6, and the numbers 2 and 4 don't cleanly divide by 6. If I try to solve for y, at some point I'm going to have to divide by 2. And 6 can be divided by 2, and 4 can be divided by 2. So y is a good candidate. Likewise, if we look at the second equation, if I try to solve for x, at some point I'm going to divide by 5. And 5 doesn't divide 3, 5 doesn't divide 6. Likewise, if I have to solve for y, at some point I'm going to have to divide by 3, and 3 doesn't divide 5, although it does divide 6, so it does one but not the other. I want no fractions if I can ever help it. So I'm going to take the first equation, so equation 1, and solve for y. That seems like the easiest choice to make in this for this problem. Now there are two ways to solve systems of equations, and honestly, if there are no good options for solving for a letter, I immediately switch to the second method, which we'll talk about coming up soon. But in this case, there is one good option, so I'm going to use that. So I'm going to subtract a 6x over. So then I get 2y equals to 4 minus 6x, and then I'm going to divide by 2. So remember, divide all the way by 2, everybody. So y equals 2 minus 3x. So I'm going to now take my second equation, which is 5x plus 3y equals to 6, and instead of the y, I'm going to use 2 minus 3x. So I have 5x plus 3, 2 minus 3x equal to 6. So distribute 6 minus 9 equal to 6. Simplify. So 5x and minus 9x, that's a minus 4x. I still have the 6. Minus 6, minus 6. And I get, okay, so this is the kind of place where you really have to keep the faith. 6 minus 6 is not 1, not 2. You know, students get very nervous when they get 0 as a result. Oh, 0 is a perfectly good number. 0. In fact, I love 0 because, you know, it makes all my answers pretty easy. When I divide by 4, which is what I have to do next to get the x by itself, 0 divided by anything is still 0. You can see how that's a nice, perfectly good number. Alright, so that's good, but I need to find the y that goes with it. So again, I'm going to use this result right there. So I already have y equals 2 minus 3x. So since x is 0, I'm going to use 2 minus 3 times 0. And that's going to be 3 times 3 times 0 is 0. So that's just going to give me 2 as an answer. So my solution is 0x 2y. And that's it. That's the substitution method second example. Alright, let's do another one. This one's going to be a little squirrely. Something strange is going to happen on this one. Solve. And So again, let me say x plus 1/3 y equals to 6. And the other equation is y equals to minus 3x plus 18. Now, I know there's a fraction here, and that makes people uncomfortable. Yes, but also say something wonderful. If you look at equation number 2, they've already solved this for y. So that's one fantastic. One less thing I have to do. So I could just literally take this result for y and substitute it in there, right? Which is exactly what I'm going to do. So I'm going to take my x plus 1/3 and minus 3x plus 18 goes in for y equals to 6. So it's an equation with fractions, and I know that we don't particularly like that, but that's okay. We know how to make fractions go away, but we first have to distribute. So that's going to be 1/3 times negative 3x plus 1/3 times 18. So that's 18 over 1, negative 3 over 1 there. That's a 6. And x plus, well, let's see, that's a negative 1, right? Those two reduce. Negative times a positive is negative x plus, over here, these reduce. It's going to be 6 plus 6. And again, this is one of those places where you really have to be disciplined about what you're doing. If you combine like terms here, you notice that they cancel and the x's drop away, and you end up by getting 6 equals to 6. Now, we've seen situations like this before, where you had the letters all vanish and you got 6 equals 6. And in these situations, when we saw these with equations, we realized that this meant all real numbers was the solution, right? So back with equations, this meant all real numbers. And likewise, when it comes to systems of equations, this means the system is dependent, or they meet everywhere. Okay, so they meet everywhere. There's 3 different ways in which you can interpret this, and they're all the same. They mean dependent, they meet everywhere. It's really the same equations, all real numbers. Infinite number of solutions are possible, right? So although we didn't recognize these 2 equations as being exactly the same, they're exactly the same. There is no difference. You could sort of see that. I can show that to you right now just to make sure you're convinced of that. If you take this equation, the easiest way to see this is if you take this one here and you were to multiply this by 3 to cancel that fraction out, you'll see you get 3x. There, the 3 and the 1/3 cancel, and you get y. You multiply that, you get 18. Notice that that's the same as this if you take the 3x to the other side. So this first equation was really the second one in disguise. Okay, so they're exactly the same line. All right, I'll do the next example on the next video.